Today we're going to build a fun and easy game. The focus is going to be on simplicity. We're not going to worry too much about any object-oriented programming practices in this session. We're not going to create any classes. We're not going to worry about instance variables, just the basics. The game we're going to be building is a stacker-based game. These are the games that you see in arcades quite a bit. They've got the blocks that move from side to side very quickly, and your job is to create as tall of a stack as you possibly can. As you get higher and higher in the stacks, the difficulty increases because the blocks move across the screen faster. So that's what we're going to be building today. Let's check out some code. This is where we'll start. We're loading the Ruby 2D library, showing the window, which you can see here. First step is to draw a grid across the screen. The grid's going to overlay on top of the blocks, which is a common feature that you see in these games. We're going to start by defining a grid size. So I think around 40 pixels will be fine for us here. And we're going to set a width and a height for our window. Now these games, because there's quite a lot of blocks vertically, we want it quite tall and not so wide. So we might say that the width will be, let's say 7 blocks across, and the height will be quite tall, so around 20. Now we can set our window width and the height as well, which will multiply by the grid size. So quite tall, not so wide. We're going to draw some lines across each of the grid components. So we're going to draw across the x-axis and also the y-axis. So going all through the x-axis, so starting from 0 going to the end of the width, in steps of the grid size, we're going to draw a line. So the line, we need the starting x and y and the ending x and y. Now because we're drawing our lines down the page, the x position will stay the same and the y will go from 0 to the height. So our x1 will be x, our x2 will also be x, our y1 will be 0, and our y2 will be the height. Okay, let's set a width of 2, and let's set a color for our grid. So I'm going to create a constant here, and I'm going to make it a very dark gray. Okay, let's give that a go. So I've got a bug here. You can see this should be x and not 2. Great, lines down the page. I'm going to do the same thing for the y-axis. It's going to be the same, just with the line swapped around a little bit. Awesome, there's our starting grid. Now let's draw our blocks. We'll draw them on the bottom row to start with. We're going to give our blocks a random color, chosen to have a few different colors. So we're going to pick between orange, yellow, and green. I'm choosing these colors because in my testing they had quite a good contrast between the background, but you can experiment and put any colors you like in there. We're going to randomly pick this color. So each time the program runs, it's going to randomly pick between orange, yellow, and green. So let's draw our active squares now. So the squares will draw on the bottom row, starting at the bottom left. So we'll set our X position. Our X position will be the grid size times the index. For our Y position, we want to start at the very bottom. We're also going to create a variable just to hold what the current line will be. So I'll create that here. That'll be useful as our game moves up. So we'll take this height and we'll take 1 away. The reason I want to take 1 away is we start at the 0th number. We don't start counting from 1, we start counting from 0. So this will be height, take 1. Size will be the grid size, and our color will be the random color we've generated. Great, you can see we've got our green blocks down the bottom. If I run the program a few times, hopefully we'll see different colors as well. Just great. One thing I want to do is change these grids to draw over the blocks. These two lines here, each of them will have a Z position, and Z is the layer that it's at. We need to set a Z position that's going to be higher than the square here. By default, the Z is just 0. So if we give our lines a Z position of 1, they should draw over the top of these blocks. Great, now we're drawing over the top. Next thing to do is move them to the right. I'm going to create a variable here just to hold what direction we're currently going. So I'm going to say the current direction equals right. And that will mean that once we get to the end of the right, we can bounce back and set that to go left. So for each frame of the program, we're going to run some code here. So we're going to put an update block here. And what we want to do is we want to say every so often move the blocks to the right. If we did it every frame, it would be really quick. This update code will run for every single frame the program draws, which is 60 frames per second by default. So we might say, every 10 frames or every 20 frames or 30 frames or so. So what I'm going to do is I'm going to say if window.frames divides evenly by some number, and that number will be 60. So 60 frames per second divided by the speed we set. And what this allows us to do is if we start at a speed as a low number, as we increase the speed for every single row that we go up, it means that the game will become faster and faster just by increasing the speed, which is really good. We'll start off the speed at 4. So that would be 4 times per second the blocks will move. So if it's time to move, then we want to move to the right. We'll check the current direction here. So we'll say case current direction. When it's right, then we will shift all of our blocks to the right. So our active squares, each of them we need to move the X position 1 more grid size across, so X. Awesome. You can see it's moving quite quickly though. The next thing is to get it to shift back to the left once it hits the right-hand side of the screen. Though I just noticed a bug here, I do need to say when this is 0. I thought it was moving a bit fast. Okay, that's better. Once it hits the right-hand side now, let's see if we can shoot it to the left. So to check if we've hit all the way on the right, we can use this active squares array. The last square in the array, when we're all the way to the right, that should have a X position of the width -1 square width. So if we take the width of the screen and we compare it to the position of the last active square plus the width of it, it should be equal to the width here. So I'll say if our last square, so if this, the X position, and we'll add on the width of it. So that should give us the rightmost side. We'll say when that's equal to, and I'll just put greater or equal to just to make sure it doesn't go over, but that shouldn't really happen. So if we say when that's hitting the width, then we'll send our blocks the other way. So we'll say current direction equals left. Okay, so it stopped moving. Now let's write some code so that it shifts back left. So it's just the same thing as this in reverse. I'm just going to copy this code here. So when we're going left, then we will take away from the x. The comparison here is a bit easier because it's the first square that will be on the left-hand side, and its x will be less than or equal to 0. And then we will change this to be right. Awesome. So blocks shifting left or right. Now what we need to do is we need to check when the user presses a key, and then it will go to the next row above. What we're going to do is, at the moment, we've got this active squares variable, and it's holding all of the squares here in each of the points here. So we're going to keep the active squares, and the active squares will then represent the next row once we press the key. But we still need to keep track of the squares below it because we need to figure out which squares, as you build this stack up, are off to the sides and should fall off. So we're going to need to also be able to look that up very quickly. So we're going to use a hash to be able to very quickly look up a coordinate and check to see if there is an existing square there. I'm going to create a new hash to store that value, and it's going to be here. So I'll call it frozen squares, and it will be a blank hash. So when the user presses any key, I don't really care what key it is, we're going to do a few things. So when they press the key, we want to shift the row that we're operating on up one. So the current line will go up one, so we'll take one away from that. We'll also increase the speed by 1 to make it faster. And now we need to loop through each of the active squares. So because we're just on the first row for the moment, we actually don't know which of the squares to keep. We should just keep all of the squares on the first one because you're not building on anything. So we'll just loop through and we're going to create a new square for each of our existing squares on the next row. Okay, so each of the active squares that are currently active, we need to freeze in our frozen squares, and it's a hash, so the key that we're going to store it against will just be the coordinates of the current square for the x and y positions. So it's going to be active squares x followed by comma and then active square y. And when we get to checking whether the blocks have something below them, this is going to make it much easier for us to do that for later. And we're going to create a new square here, and we're going to copy the values from our existing square that we've been given. So the active square here. So we're going to copy the x, we're going to copy the y, the color will be the same, so it'll just be the block color, and the size of it will be the grid size. Now that we've stored our active squares in the frozen squares hash, we can now create new active squares on the level above. Before we do that, we'll clear out our existing active squares. So I'm going to call remove on each of them, and that will actually remove them from Ruby 2D, so they'll no longer render on the page. I'm also going to clear out this array. If I would just clear out the array, they would still render on the page. So we do need to do this just to make sure they're not visible. And now let's go through and now let's create a new set of active squares. So we don't actually know where those will be. So what I'm going to do is I'm going to start all the way on the left, and I'm going to go through all of the grid positions horizontally. And we're going to check to see, is there an active square, or a frozen square, sorry, below it. And if there is a frozen square, then I can draw above. If there's not, it means that our square has kind of fallen off the edge, and it shouldn't be rendered out on this new row. So let's do that. So we're going to loop through each of the positions and we're going to draw a new square. So this X position will be the grid size times the index that we're looping through. So as we go through, that'll be the first position and the second and so on. So it's going to go from left to right across the page. And the Y position will be the current line. And because we've increased the position of our current line, so we're going in the Y direction, we're taking away from our Y, this will be on the next line above. And now we need to check to see if there's anything below us. So we'll use the frozen squares that we've made now. And we'll say, hey, do you have a key for this X position, comma, and then we're going to check to see if there's anything below us. So we're going to take our Y position, but we're going to add in one extra grid size. So it'll be the block below us. And if there is something there, then we're going to add a new active square. And here we're going to create a new square again. So X will be in the X position, Y, Y. Color and size are the same. So let's give that a go now. Okay, I'm going to press any key on the keyboard, doesn't matter which one. And I'm getting an error. It's on line 71. When I look in 71, I can see that instead of timesing the line number by the grid size, I'm timesing it by the color, which is not going to work. Let's fix that and see if it works now. Awesome. So I'm pressing enter and you can see the grid's building up. So that's working really awesome. What it's not actually doing is it's not letting these ones that are on the side fall off. So there's one more step that we need to do to delete any old blocks that haven't stacked above existing blocks. And that is here. So at the moment we're freezing all of the squares. We only want to freeze the squares when there is something below them as well. So we're going to do a similar thing to what we did here. The problem we're going to have is on that first row though, we don't have anything below us to check. So we're going to just put in a check here initially to say, hey, are we on the first row? And if so, then just let anything work. So here I'm going to say if the current line is the last one, and the last one would be height -2. The reason why it's -2 is by the time we get here, we've already taken 1 away from it. And we started off with height -1. So it's going to be height -2 to say we're on the first line. So for the moment, let's just do this if we're on the bottom line. Okay, cool. And you can see it works for the first line, but it doesn't work for subsequent lines. So we need another check here, also to check to see if you're not on the first line, then check if there's a block below you. And this is going to look exactly the same as this code here. So frozen squares has key. We're going to check this active square .x, comma, and then active square .y, and we're checking the one below us, same as what we're doing here. So this we plus the grid size. Awesome. So now because we're checking below us, making sure that we'll only freeze a block if the block has something directly below it, it means that our game is working as intended. One thing we do need to add is what happens when we get to no blocks. So I'm going to just press enter with the block off to the side, and you'll notice that the program gets an error here. So undefined method X for nil class. The line here is line 41. So let's have a look at this line here. And it's this code here. So because we don't have any active squares, because the active squares are empty, when we call last, it's giving us nothing, and this code is failing. But that's okay, because if our active squares are empty, it means that the game is actually finished entirely. And so what we should do is we should just show a game over screen, which is what we'll do. So let's only run this code if we've got any active squares. So I'll say if active squares are empty, then we're going to show some game over text. So I'm going to say text.new, can say game over. I'm going to make the text a bit large so we can read, and I've already played a bit around with the position. So the X is 60, Y is 80 here, and I want the text to be on top of everything. So I'm going to use a Z of 2, so it should be above the squares, but also above the grid here. So if it's empty, do that. Otherwise, we can run our regular game logic. Okay, let's see if we can lose now. Oh, I'm doing too well. Excellent. Game over. So it's correctly seeing the end of the game now. Last thing to do is to add some scoring in. I'm going to create a new score variable here. We'll start it off at 0. And each time that we press a key, we're going to add the frozen squares to our score. So we'll look at the number of frozen squares and just set the size. So each time you press the key, we'll look at how many squares are entirely frozen, and that's the score. And lastly, we can show some text on the screen. So we'll add some new text here. We'll say your score is score, and we'll just position this just to be slightly under the other text. So let's see if we can do that here. Gonna run our game once more. Great. So you can see it's now working. Score is 11. There's a link in the description to GitHub with all the code for this tutorial, as well as all my other tutorials. If you want more simple tutorials like this, I built out a snake game, and you can see the link for that here. If you want a more in-depth tutorial, then I'm also building asteroids in a multi-part series, and you can check that out here. Until next time, see ya.